Hey everyone, welcome to The Explainer. Today, we're diving into something totally fascinating, a deep dive into a very specific, highly optimized cognitive architecture. Have you ever looked at someone operating at the absolute peak of their field and thought, man, how does their brain actually work? Well, we're going to reverse engineer that exact mindset today, and we'll do it by looking at what happens when you take a really high-powered intellect totally out of its natural habitat.
Okay, let's dive into this. It's kind of a paradox, right? Why would the ultimate builder, someone who literally thrives on solving massively complex problems, find vacations absolutely torturous? You'd think sitting on a beautiful beach with a drink would be the ultimate reward. But, for a certain type of brain, going on vacation isn't relaxing at all. Actually, it feels like pure torture.
To really get this, we're going to look at a case study based on a real persona. We'll just call them the friend. Now, this friend finds traveling, the sightseeing, walking around historic cities, just incredibly boring. But they will happily spend hours at home intensely researching complex financial option strategies or debating system architecture with an AI and find it absolutely thrilling. So, why the massive disconnect here?
Section 1. The Builder versus Consumer Illusion. So to make sense of our paradox, we first have to totally dismantle this really common myth. There's this false dichotomy out there that you're either a pure consumer, just passively soaking up sensory thrills, or you're a pure builder, only wanting to construct things and solve problems. But for a healthy, typical brain, life is actually this dynamic balance. You need sensory consumption, like lounging on a beach or having a great meal, to lower your cortisol and get that relaxing hit of dopamine. But you also need the endorphins and the neuroplasticity that actually come from building. I mean, even a standard vacation has building elements, right? You're managing logistics, navigating a new culture, fixing travel hiccups. We're constantly bouncing between consuming to recharge and building to find meaning.
But what if your brain completely rejects that standard balance? The friend from our case study is basically an anomaly. Their brain doesn't get recharged by normal consumption, it just gets frustrated. And that anomaly is the central mystery of our explainer today. To grasp why they reject this balance, we need a totally different metaphor for how their mind operates.
Section 2. The 4K processor brain.
Now, what's really interesting about this is if you think of this specific cognitive architecture as a high-end, top-tier piece of hardware, like a 4K processor brain. And hey, this isn't about being arrogant, it's just recognizing that different minds require completely different levels of data density to run smoothly. When you break down the information density of their inputs, their struggle makes total sense. Think about being a tourist. The data input is actually super low frequency. It's mostly just passive visual changes. You walk a bit, look at a building, maybe stare at a statue. Contrast that with options trading or AI system architecture. That is high-frequency dynamic modeling. You're constantly calculating risk, macroeconomics, algorithmic logic. So for a 4K processor brain, running a low-resolution game like Sightseeing just leaves way too much processing power sitting totally idle. In computer science, when a lightning-fast processor has to wait for a slow hard drive to catch up, that's called an input/output bottleneck. Well, in the real world, this 4K brain experiences a physical I/O bottleneck. The sheer speed of physical actions, like walking to the next tourist trap, literally cannot match the speed of their thoughts. Their cognitive weight groups are just sitting empty. And biologically, that idle time triggers something called psychic entropy. Basically, it's a deep, creeping sense of boredom and, honestly, anxiety.
Section 3. Escaping physical I/O bottlenecks.
So how exactly does a brain like this escape the torture of a physical bottleneck in the real world? Let's test it out with a completely mundane activity, picking mulberries at an orchard. Now, at first glance, this seems like a nice, relaxing consumer activity, right? But for the 4K brain, it instantly turns into a puzzle. Let's call it the mulberry problem. They immediately use linear regression to figure out the pattern. Oh, branches with the most sunlight have the sweetest, darkest fruit. They optimize their physical route so they don't get stained. But here's the catch. They hit the algorithm ceiling in exactly 3 minutes. Once the pattern is cracked, they're just trapped in a super slow biological loop. Reach, pick, drop. The boredom immediately sets right back in.
Let's move on and say how this builds, because watch what happens when they forcefully try to escape that boredom through metacognitive restructuring. Since the physical act of picking is just way too slow, their brain reframes the entire orchard into a business model. Suddenly, this boring, low-dimensional farm transforms into an infinite, high-dimensional puzzle. They start calculating the throughput of the parking lot using queuing theory. They're assessing the marginal costs of the land versus the premium of selling a farm experience. They aren't picking fruit anymore. They are architecting a microeconomy.
Just imagine asking this brain if the farm should charge, say, $5 to rent out the picking baskets. They wouldn't just give you a simple yes or no. They'd run a full system stress test right on the spot. They'd instantly see that charging $5 introduces fatal transaction friction. Visitors will just use their hands and pick way less fruit. But providing massive, free baskets, that leverages the psychological anchoring effect. People feel this urge to fill up the empty space, exponentially boosting the average revenue per user. This brain absolutely loves finding these high-leverage feedback loops. It's really not about the fruit at all. It's about optimizing the system's throughput.
Section 4. Read-only versus read/write systems.
This actually brings us to a crucial distinction in how this cognitive architecture categorizes, well, everything in the world. It fundamentally divides reality into two distinct types of systems. Let's compare two facts. Fact 1, you aren't supposed to eat food while walking on the streets in Japan. Fact 2, implied volatility crush in options trading. Now, the cultural rule about street food is a homeostatic, hard-coded system. It's a static fact meant to maintain order. There's literally zero arbitrage to be found there. But IV crush? That is a highly dynamic algorithmic event where market consensus mathematically collapses. One is just a flat rule you have to memorize. The other is a mathematical absolute that you can actually leverage.
In that cultural system, the 4K brain basically feels like an NPC, a non-player character. It's completely a read-only experience. To comply with the rule of not eating on the street, you just have to shrink your own variables and obey. There's no feedback, just silence. But the financial algorithm, that offers a read/write experience. You inject your own strategy, and the system responds back with brutal honesty and nonlinear rewards. In that system, you are definitely not an NPC. You are the architect.
Section 5. The Ultimate Reductionist.
All right, we are entering the final layer of the onion here. What is the actual core algorithm driving this relentless search for complex, high-leverage systems? Well, it boils down to something called cognitive compression. You see, this brain isn't just hunting for useful trivia. It's hunting for first principles. It wants to take the massive, high-entropy chaos of the universe and compress it down into a single, elegant, self-contained logical truth. For this mindset, true understanding is quite literally defined as compression.
And this brilliantly illustrates what that perfect logical closure actually looks like. The formula here is the scaling law for training massive AI models. 2ND plus 4ND equals 6ND. At a quick glance, this might just look like some random piece of tech trivia. But to the ultimate reductionist, this is profoundly beautiful.
Here's why. It strips away all the black box magic of artificial intelligence. It takes the multi-million-dollar, super-hyped AI industry and violently reduces it into basic math. The second part, that's just the forward pass, simple matrix multiplication using basic arithmetic. The 4ND is the backward pass, calculating gradients using the chain rule from calculus. Suddenly, the most complex, mind-bending engineering feat of our era is compressed into basic addition. 2 plus 4 equals 6. Boom, a massive aha moment.
And honestly, the truly fascinating part, the ultimate reductionist doesn't even need this math to be practically useful in their day-to-day life to feel that rush. The pure structural closure, the absolute absence of entropy, is the ultimate reward all on its own. It is, as they describe it, the sound of gears perfectly meshing without any black boxes. It's the sheer aesthetic beauty of logic proving that the world at its very foundation is actually neat, tidy, and mathematically sane.
So, as we wrap up the explainer today, I want to leave you with a question to kind of reflect on regarding your own cognitive architecture. When you walk through a brand new city or just navigate your everyday workday, are you simply observing the world as a read-only participant? Or, like our ultimate builder, are you constantly trying to access its source code? Something to think about. Thanks so much for joining me on this deep dive, and we'll see you next time.